Hi all, now that it is almost 6:06, we'll start our today's session. So I'm Clarice. I'll be taking the third problem solving session of spectroscopic techniques for pharmaceutical and biopharmaceutical industries. And today I'll be discussing about a couple of problems that is pertinent to rotational spectroscopy. So to start with, so we have been strictly instructed not to discuss any assignment questions. So I'm not discussing anything that is related to the assignments. So let's start with one of the problems from rotational spectroscopy. So here we have been. So this question is about rotational constant. So rotational constant of 1H13C chlorine is observed to be 10.1 second. Yeah. So this is observed to be 10.5909 centimeter inverse. Hello, I hope I'm audible to all of you. Am I audible? Can one of you confirm?
Yes.
Thank you. Yeah. So the rotational constant for 1H13 1H proton and 35 chlorine is observed to be 10.5909, and we have been asked to find out what are the rotational constant B values for 1H and 37 chlorine, and for 2 deuterium 35 chlorine. So we know that the rotational constant B is equal to h cut square by 2IHC. I'm going to rewrite the formula. We know that h cut is equal to h by 2 pi. So this is going to be h square by 2 pi the whole square 1 divided by 2IHC. We can cut off the h from the 1h from numerator and denominator, and 2 pi square becomes 4 pi square. 4 into 2 becomes 8, right? So this will become, or h by 4 pi square 1 by 2 IC. Can write it as h by 4 into 2 8 pi square IC. This way I'm just rewriting the formula so that my calculations are way much more easier, where I is the moment of inertia and c is the speed of light, which is 3 into 10 to the power 8 meter second inverse. I is equal to mu r square, where mu is given by m1 m2 by m1 plus m2. Okay, so we don't know what is the r, the bond length, right? So between a proton and a 35 Cl, we don't know what is the bond length, and we are going to assume that the bond length r here is going to be same for the bond length is going to be same as what we are going to assume all throughout. Okay, so let's find out what is r from the rotational constant that has been given for proton 13.5 Cl. So for that, first we have to find what is mu for that. So for mu is equal to m1 m2 by m1 plus m2. Okay, so for m1 corresponding to for this particular system is 1 AMU for which is for proton. For chlorine it is how much is the molecular weight of 135 chlorine? So it's going to be it's going to be 35 AMU. So this is for 35 chlorine. So it's going to be 1 into 35 divided by AMU 1 plus 35. So this is 35 divided by 36 AMU. Now we have to calculate what is the now we have to calculate how much is this in kilograms. So this is 35 divided by 36. Okay, 1 AMU is equal to into 10 to the power minus 27 kilograms. So this is going to be we have to make everything in in the appropriate units to get the correct answer. So that's why I'm converting it to the kilogram. So while we are doing the calculations, 35 divided by 36 into 1.67. So this is equal to 1.62 into 10 to the power minus 27 kilogram. So for this particular system, the mu value is 1.62 into 10 to the power minus 27, and we have to calculate what is the I. Oh no, yeah, we don't know what is the R value, so we are supposed to calculate what is the R value. So we know B is equal to H by 8 pi square IC, where I is equal to 8 pi square I, where I is equal to mu R square C, and we are supposed to find what is R. So R square is equal to H by 8 pi square mu CB. Now we have to yeah, now we have to find substitute all the values. We know what is mu, which we have calculated here. We know what will be there for H. H is 6.626 into 10 to the power minus 34 joule second. B is in centimeter inverse. So this is 5909 centimeter inverse. We know what is C. So we are supposed to find what is R square. So C is 3 into 10 to the power 8 meter second inverse. We can convert this meter second inverse to centimeter second inverse, so that we can cut it with B value, because B is already in centimeter. So this one is 3 into 10 to the power 10 centimeter second inverse. So R square is equal to 6.626 into 10 to the power minus 34 divided by 8 into pi square. Mu is, okay, sorry, mu we have calculated as 1.62 into 10 to the power minus 27, and C is 3 into 10 to the power 10, and this is joules seconds, sorry, this is in kilograms, and this is in centimeter second inverse. This is in centimeter inverse. Now when we do the math, we'll have 626 divided by 8 into pi square 1.62 3 into 10.5909. This makes it as 1.63 into 10 to the power minus 3, and we have to take into account of all the power values here, which are 10 to the power minus 34, and whatever is in the denominator will come as 10 to the power plus 27, 10 to the power minus 10. So when we make all these, when we adjust all the powers, it will be like 27 minus 34 1.63 into 10 to the power minus 20. This will be in meter, because we are using joules, and everything else is in appropriate units. So this is the value of R square. Now we have to find what is R. So for that we can take square root of 1.63 into 10 to the power minus 20. So this will be root of 1.63 into 10 to the power minus 10 meter. So this is 1 second. Yeah, this is coming to be 1.27 into 10 to the power minus 10 meter. So the R value here is around 1.27 into 10 to the power minus 10 meter. So we from the rotational constant of 1H13.5 Cl, we have gotten what is the interatomic distance between proton and chlorine, and using that interatomic distance or the bond length, we are going to calculate what is going to be the rotational constants for 1H37 chlorine and 2 deuterium 35 chlorine. So I don't think I'll have space here, so I'm going to add a new slide over here. Yeah, this should do. Yeah, so we have to find what is the rotational constant from the, we have already derived that the rotational constant can be written as h by 8 pi IC. So I'm just taking that 8 by 8 pi square IC, and we have to find how much is it for proton and yeah. So we found what is the R value. R value which is the interatomic distance, and we found out it to be 1.27 into 10 to the power minus 10 meter. Okay, now for proton and 37 chlorine, which is attached by a single bond, and the bond length to be 1.27 into 10 to the power minus 10 meter. Let's calculate what is the, so where I in this equation, the moment of inertia is mu r square, and let's find what is mu for this particular system. So mu is m1 m2 divided by m1 plus m2. So this is equal to 37 into 1 by 37 plus 1. So this is going to be, this is in AMU unit, so we need to find it in kilograms. So this is 37 by 38 into 1.67 into 10 to the power minus 27 kilograms, and this will be equal to 37 divided by 38 into 1.67. This is so let's calculate how much is B. So B is going to be 6.626 into 10 to the power minus 34. This is in joule second. 8 into pi square. Instead of I, we have mu. Mu is 1.626 into 10 to the power minus 27. R is 1.27 into 10 to the power minus 10. And C is C is 3 into 10 to the power 8 meter second inverse. So this is 3 into 10 to the power 8. This is in kilogram, this is in meter, this is meter per second. So this will come to yeah, so this will be 6.626 divided by 8 into pi square into 1.27 into 3. This is 2.2 into 10 to the power minus 2. We have to account for all the powers. 10 to the power minus 34, 10 to the power minus 24. Why is it 24? It's minus 27, sorry. When we take whatever is in denominator to numerator, the sign will change. So that's why it becomes 27 when it becomes numerator. This will become 10 to the power minus 8. Sorry. This will be in meters. 1 second, let me joules second is in and the denominator will have kilogram, meter per second. Okay, yeah, I made a mistake here by not putting square for this particular one, which makes our calculations wrong. Yeah, we should have squared. So okay, so our B is equal to h by 8 pi square IC. I can be written as mu r square, so it is 8 pi square mu r square C. So h is 6.626 into 10 to the power minus 34. 8 pi square into mu is 1.626 into 10 to the power minus 34 minus 27 and r has to be squared, which is 1.27 into 10 to the power minus 10 the whole square multiplied by c. C is 3 into 10 to the power 8. So when we do the calculation, it will be like 6.626 divided by 8 into pi square into 1.27 square into 3. So this is equal to 17.36 into 10 to the power minus 3 into 10 to the power minus 34, which is from the numerator itself. Whatever is in the denominator as minus 10 to the power minus 27 will become 10 to the power 27 when it comes to numerator. And 10 to the power minus 10 square is going to be 10 to the power minus 20. When it comes to the numerator, it will become 10 to the power plus 20 multiplied by 10 to the power minus 8 in the denominator will become 10 to the power minus 8 in the numerator. When we calculate for all the power values, it will become 1 second. There is some problem with the calculation. Okay. 27 plus 20 minus 34 minus 8. Okay. Check plus 2 meter inverse. So we have to find how much is it in centimeter inverse. So 1 centimeter one meter is equal to 100 centimeter. So 1 meter inverse is equal to centimeter inverse. So 1 meter is 100 centimeters. So 1 meter inverse is 10 to the power minus 2 centimeter inverse. So this is going to be 17.36 into 10 to the power 2 into 10 to the power minus 2. When we are converting this meter inverse to centimeter inverse, this will become like this. So it is going to be 17.36 centimeter inverse. So this is for when it is proton and 37 Cl. Now the next part of the first part was to find what is the distance between these two. The second part was to find what is the rotational constant when it is proton and 37 Cl. Next thing is when it is deuterium, when it is 2 deuterium and 35 chlorine. So let's have a new slide for that. Yeah. So here we have to find how much is this particular thing going to be. P is equal to H by 8 pi square IC, and here it is 2D and Cl35. We have to first find what is mu. Okay, let me just write down. So we have to find what is mu. It is 8 pi square mu r square c. Mu is what we have to find for the particular system. R has been taken from the previous calculation that we have done. We know what is H and C. So mu we'll calculate as m1 m2 divided by m1 plus m2. So this is going to be 2 into 35 divided by 35 plus 2. this much AME. So this is going to be 35 into 2 is going to be 70 divided by 37 AME. Now we have to convert this to kilograms. So this is going to be 70 divided by 37 into 1.67 into 10 to the power minus 27 kilograms. So 70 divided by 37 into 1.67. So this is 3.15 into 10 to the power minus 27 kilogram. So let's put in the formula B. H Planck's constant being 6.626 into 10 to the power minus 34 joule second. 8 into pi square into mu is 3.15 into 10 to the power minus 27 into r square is going to be r is equal to 1.27 into 10 to the power minus 10 meter. So this is 1.27 into 10 to the power minus 10 into this should be squared, and c is 3 into 10 to the power 8 meter per second. By doing the calculation for this particular system, it is 6.626 divided by 8 into pi square into 1.27 square into 3. This is 17.3 into 10 to the power minus 3 into 10 to the power minus 34 into 10 to the power plus 27, 10 to the power plus 20, because whatever is in the denominator will go to the numerator and it will inverse its power sign. So this is also again converting this meter inverse to centimeter inverse. This will become 10 to the power minus 2 centimeter inverse. This will be 17.3 centimeter inverse. Yeah, so that's where we found out what is the B value for 2 deuterium 35 chlorine. So we are done with this particular one. Now we'll move towards the next problem. The other thing is, yeah, the difference that you will see in the B values between these three numbers will be in the later in the higher decimal points, which I have not included. That's why you would see both of them are almost the same, 17.36 versus this is also 17.36. I think it will happen at the later on values, like this will be 0.9. I don't know, I forgot how much I had gotten for proton and 37 chlorine. The values, the difference in values are going to be in the later on decimals, that's why you are not able to see it. There is some difference. I feel there is something that is different that I'm calculating in terms of converting AMU to kilogram. I think it is going to be 1.66 rather than 1.67. When you do the calculation according to 1.66, I think you will get a better estimate of B values. Anyway, I'll check it and get back to you in the next tutorial session. The next question is going to calculate the frequency of frequency of transition for a um, for for a transition of J value from 4 to 3 in the pure rotational spectrum of 14N16O, the equilibrium bond length to be 115 picometer. So the R value here is 115 picometer. So this is equal to 1.115 angstroms, or this is equal to 1.15 into 10 to the power minus 10 meters. Now we have to find what is the energy of transition between J equal to 4 to 3. So we know that energy of transition is equal to h cut square by 2I J into J plus 1. We can also write it in terms of B value, but right now I am focusing on this particular formula. So if you have E is equal to h cut square by 2I into J plus 1. This is in joules. Yeah, we can, if we want this thing in so this we have been asked to find the frequency, so we need to find how much is it in how much it is in hertz. So this can also be written as h square by 8 pi square I, because h cut is equal to h by 2 pi. I just substituted h cut square as h square by 2 pi the whole square. So we'll get this particular formula. This is also in joules. Now we have to find how much is it in hertz. So E is equal to h nu. So we are supposed to find how much is the nu. So nu is equal to E by h. So this is going to be h by 8 pi square I J into J plus 1. Yeah, so J into J plus 1. Now we have to calculate what is the okay, so we are calculating what is we have to find what is the energy gap between 4 and 3. So nu 4 minus we have to find what is delta nu, which is nu 4 minus nu 3. So nu 4 is going to be h by 8 pi square I 4 into 5 minus h by 8 pi square I 3 into 4. So this is going to be h by 8 pi square I we can take in common, and it will be 20 minus 12. This is going to be okay, this is going to be h by 8 pi square I into 8. So we have to calculate how much is the so we can just cut off this to 8, and it will be h by pi square I. So I is equal to mu r square. Now we have to find out what is mu. Mu is equal to m1 m2 divided by m1 plus m2. So here m1 can be taken as 14 and m2 can be taken as 16. So okay, 14 into 16 divided by 14 plus 16, and these values are in AMU. So this is going to be 14 into 16 divided by 14 plus 16. This is 7.466 AMU, and converting this to kilogram, this is 1.66, not 1.67, into 10 to the power minus 27 kilograms. So this is 12.39 into 10 to the power minus 27 kilograms. And R here is 1.15 into 10 to the power minus 10 meters. So substituting these values, H is, which is Planck constant, which is 6.626 into 10 to the power minus 34 joule seconds, pi square, I is mu r square, mu is 12.39 into 10 to the power minus 27 kilograms, into r square is 1.15 into 10 to the power minus 10 the whole square. This is in meter square. Yeah. So this is going to be 6.626 divided by pi square is 3. So when we do the math, it will come out to be 4.1 into 10 to the power minus 2 minus 34 into 10 to the power 27 into 10 to the power 20. this will come out to be so 4.1 into 10 to the power 11 second inverse. We can calculate how much the units come to be. So 1 joule is equal to kilogram meter square per second square, and the in case of numerator and denominator, the kilograms will cancel out, meter square will cancel out, and there is a seconds here and second square inverse here, so that will cancel out to be second inverse, which is the total final unit of the final unit. So this is coming to be 4.1 into 10 to the power 11 seconds, second inverse. So this is going to be the frequency of J of frequency of transition from J is equal to 4 to 3 in a pure rotational spectrum of 14 and 16 O with a bond length of 115 ppm. So this is how we calculate the frequency of transition when we have given two particles which are bonded in with its molecular weight, and if we have given what is the J for the transition. So this is also a similar question in the similar line, where we have given a wave number, which is like we have given what is the wave number over here and we have been asked what is the, so here it is going from, or it would rather come from here to here, from J is equal to 3 to 2 it is coming, and the wave number nu bar is going to be 63.56 centimeter inverse, and we have been asked what is the moment of inertia, which is I, and what is the R value. So it's sort of like a reverse calculation for the same same process. So yeah, so here we need to calculate how much is the so the energy of a state at a quantum number J is given as h square by 8 pi square I J into J plus 1. This is in joules. The corresponding wave number for that, or like a corresponding value in wave number, is going to be h by 8 pi square IC J into J plus 1. This is in centimeter inverse. Now we have to find how much is delta nu coming from 3 to 2. So nu 3 minus nu 2. So this is going to be h by 8 pi square IC 3 into 4 minus h by 8 pi square IC 2 into 3. So this is going to be h by 8 pi square IC 12 minus 6. So this is going to be h by 8 pi square IC. So this is going to be into 6. So this can be cut off to 3 by 4. So 3 by 4 h by pi square IC. Now we don't know what is, so the first objective is to find what is I. So we have been given what is delta nu 3 to 2. So our first objective is to find what is I. I is equal to 3 by 4 h by pi square c delta nu 3 to 2, and okay, let me write down all the parameters here. 3 by 4, h is 6.626 into 10 to the power minus 34 joule second. Pi square c is 3 into 10 to the power 8 meter per second. This can be 3 into 10 to the power 10 centimeter per second. So this is 3 into 10 to the power 10 centimeter per second. Because my wave number is in centimeter inverse, so I just want to cancel both of them. So this is 63.56 centimeter inverse. So while we calculate, this is going to be 6.626 divided by pi square into 3 into 63.56. So this is going to be, okay, and I didn't, and we also have this prefactor of 3 by 4. So this is 2.64 into 10 to the power minus 3 into 10 to the power minus 34 into 10 to the power minus 10. Okay, so this is going to be seriously, so this is 2.64 into 10 to the power minus 47 kilogram meter square. Okay, now we have been given we have gotten what is the moment of inertia of molecule. Now we have to find what is the bond length. So we know bond length H value in erg. What do you mean by erg? Okay, if you want to find what is the values, exact units coming out to be, so I can write, yes, H value is mentioned is in joules per seconds. So 1 joule is equal to kilogram meter square by second square, right? So this is kilogram meter square by second square, and you have a seconds here. Because it is joule seconds. So centimeter inverse and centimeter will cancel out. You have a per second here, which will go here as second in the upper place. So that makes it as a second square. This will go here, up here, and make it a second square. And these two second square will cancel out, and it will become kilogram meter square. Yeah. Okay, the second part of the problem is to find the bond length from moment of inertia. So we have to find what is R. So I is equal to mu R square. So R is equal to I by mu square root. Now we have to find what is mu for this particular molecule. So this is 1H 35 Cl. So we have we have find in the previous question how much is the mu value for proton and 35 Cl. So it is 1.62 into 10 to the power minus 27. So this is 1.62 into 10 to the power minus 27 kilograms. So if you have and the I value is 2.64 into 10 to the power minus 47. Now we have to find what is R. R is equal to square root of 2.64 into 10 to the power minus 47 divided by 1.62 into 10 to the power minus 27. So this is going to be 2.64 divided by 1.62 to find the square root of 1.27 and into 10 to the power minus 10 meters. So square root of 2.64 divided by 1.62 will give you 1.27 and square root of 10 to the power minus 47 divided by 10 to the power minus 27 will be equal to 10 to the power minus 20. This is, I hope so, one second. Yeah, so this is going to be square root of this particular thing is going to be 10 to the power minus 10 meter. So this is the bond length corresponding to 1H attached to 35 Cl. We are almost towards the end of today's session. I have one more question which we will be discussing in the next tutorial session. I think we are already overshooting the time today. We will discuss the next question in the next tutorial session. Yeah. With this, I would like to end today's session. I think there is a couple of mistakes that I have made with question number 1. One of which is this is not exactly 1.67, this is 1.66. Please calculate according to that and get the correct value. And you are not just supposed to take only first couple of decimal points. You are supposed to take a couple more decimal points here. Please take those couple more decimal places and repeat the calculation to get the correct answer. So there is some problem with the calculation that I have done. Please make sure that you don't make those mistakes. Yeah. That's all I have to discuss with you today. If you have any particular question with the questions that we discussed today in the tutorial, problems that we discussed today in the tutorial, please let me know. Yeah, if you all don't have any question, I would like to end the session today. Thank you all for joining.